Good morning. This is Kali Gurumurthy, Associate Professor in Department of EEE from Velamal Institute of Technology. Today we are going to discuss about DC motor characteristics. We know that motor is converting electrical energy into mechanical energy. In motor there are two main parts. One is stator, another one is rotor. Stator consists of field winding, rotor consists of armature winding. Based on the two winding connections, the DC motor is categorized into three. One is shunt motor, series motor, compound motor. In shunt motor, the armature winding and the field winding are connected in parallel. In series motor, the armature winding and field winding are connected in series. In compound motor, based on the connection and also the number of field winding, it is classified into two categories. One is differential compound motor, another one is cumulative compound motor. The compound motor having two field windings, one is series field winding, another one is shunt field winding. In cumulative type of compound motor, both windings, both field winding, series winding, shunt winding, producing the fluxes phi series, phi shunt respectively. The net flux will be sum of these two fluxes. But in differential type compound motor, the net flux will be difference between these two fluxes. These are all basics of DC motor types. Now we are going to discuss about the characteristics of DC motor. In characteristics of DC motor, three characteristics will be discussed. First one is torque versus Ia. Second one is speed versus Ia. Third one is speed versus torque. Torque versus Ia and speed versus Ia are called as electrical characteristics. Speed versus torque is called as mechanical characteristics. Now we are going to discuss these three type of characteristics for shunt motor, series motor and compound motor. The first one, torque versus Ia. For the shunt motor, the basic torque equation, torque proportional to phi Ia. The basic torque equation, the torque is proportional to phi Ia. In the shunt type of DC motor, that is shunt DC motor, the current through field winding is constant. So the flux produced will be constant irrespective of load, irrespective of the armature current. The flux produced in the field winding remains same. So the shunt motor is called as constant speed motor or constant flux motor. So in the torque versus Ia characteristics, in shunt motor torque proportional to Ia because flux is constant. When there is no load, current become 0. If current 0, torque become 0. So it is it will start with the origin. When we increase the load slowly, the Ia increases, so that torque increases linearly. This is the characteristics of shunt motor for torque versus Ia. But this is called armature torque. But shaft torque is little different from armature torque, because when we start from no load condition, some friction will be there. Some friction will be there. To overcome this friction, it will take some no load current Ia naught. So it will be marked here. Under no load, current is there, but there is no torque. So the shaft torque starts from this point A, but the armature torque starts from point O. Next, in series motor, when load increases, the Ia increases, the field current also increases, because the line current, field current, armature current are the same. So as per the basic torque equation, torque proportional to phi Ia, when Ia increases, that is load increases, Ia increases, so that If increases, so that flux increases. When Ia is 0, If will be 0, flux will be 0. But this situation will not occur in DC series motor, because we could not start the series, we should not start the DC series motor without any load. We will discuss this point in second characteristics, speed versus Ia. Now torque versus Ia characteristics. Since the flux is proportional to Ia, the torque final basic equation is changed to torque proportional to Ia square. So the speed torque characteristics will be like this. Since it is proportional, the speed torque characteristics will be like this. At till certain value of Ia, the torque varies in a parabolic way. Exponentially it will vary. After that it will be vary linearly. It is linear because the flux will be saturated after some time. Irrespective of current, the flux will be saturated. This is coming under BH curve. So beyond this limit, certain limit, the flux remains constant, torque proportional to Ia only, so it will be linear. Till this, the torque proportional to Ia square, here torque proportional to Ia. So this is the speed torque characteristics for series motor. Then speed torque characteristics for compound motor. Here we have two category: differential compound motor and cumulative compound motor. As we said, the torque proportional to phi Ia. when we take the compound motor, it has series field winding, shunt field winding, and this is armature winding. In differential type, the net flux is difference between these two, that is series flux and shunt flux. In cumulative type, the net flux is shunt flux plus series flux. So the speed torque characteristics will be already we told that torque proportional to phi Ia. In cumulative type, the flux value will be added, because in cumulative type net flux is phi shunt plus phi series. So we know that in a shunt motor it will be linearly increased, but in cumulative type compound motor, since the torque is proportional to phi Ia, the flux value increases with respect to load, so that it will be above the shunt line. This is, we know that this is shunt characteristics, torque versus Ia. So like this, the compound motor cumulative type will have the torque versus Ia characteristics. The line will come above the shunt line. Similarly, the torque proportional to phi Ia, the differential type of compound motor, the net flux is phi shunt difference of phi series. So since flux decreases, the torque value will be decreasing. So this is for differential type.